Boolean algebra is a very useful and clever way to simplify digital circuits, and that's the focus of this tutorial. Boolean algebra introduced by George Boole in 1854, and of course the purpose of it is to facilitate the analysis and design of digital circuits. That is why it's indispensable that we look at the properties of Boolean algebra and of course know them by heart. There are 6, and we shall look at them one by one, okay, together with their respective equations. So the first property is the commutative property, which states that the order in which 2 Boolean variables appear in a Boolean function is not significant. So pay attention to the English words being used, because the properties are very much clear. Once you understand what the property is stating, it's easy for you to come up with an equation like this one and this one. So whether we are ANDing or we are ORing, the property is going to work for both. As you can see here, we have A plus B, which is equal to B plus A, meaning that whether you start with A then B or B then A, it's the same thing. It's not important. This word here is of no significance at all. It's not important. Like, it will not in any way affect the results, okay? Same as when you're using the AND gate. If you start with A, AND it with B, or B then A, it's not important. It will not change anything. It's the same thing. It doesn't matter how you arrange your Boolean variables. It doesn't matter. Now the second, which takes us to the second property, that is the associative property. Now the associative property states that the order of ORing and ANDing is of no consequence. So if you take note, the first law, which is the commutative law, if I take you back, it's talking about the variables. The order in which these Boolean variables are arranged is not important. Then the associative law is talking about the gates themselves. The way you're going to do the ORing and the ANDing has no consequences at all. So you see this clearly when we start minimizing the Boolean equations. So associative property, as you can see the equations, the first one is you can do A plus B plus C is the same as A and then B plus C in brackets. You can arrange them like this. You decide first of all to add A plus C, then the answer you get, you're going to add it to A. It's the same thing if you add at the same time A plus B plus C, or you add A plus B, then the answer you add it to C later. It has no consequences. You still get the same results. Same here if you use the AND gate. If you do A and B and C at the same time, it will give you the same results. If you start with maybe B and C first, since we start with brackets, usually in any equation, you start with the brackets off the BODMAS thing. You get rid of the brackets. That's when you now take the answer and AND it with the A, which is outside. You still get the same results. There are no consequences. Or if you start with AB, then C last, it's still the same thing. So, which qualifies that the order of ORing and ANDing is of no consequence. So there are no consequences if you choose to arrange your gates in any way as illustrated here. So if you are told to define and give an example, you need to define the property rightly and of course give the right equation. The secret is, if you understand the laws, you can come up with these equations without memorizing but knowing. Which takes us to the third property, the distributive property. This shows how a Boolean variable is distributed over an expression with which it is ANDed. Again, pay attention to what the law states. The law says for distributive, it shows how a Boolean variable is distributed. So let's say we've picked A here. This is the Boolean variable we've picked, A. So it's going to show how A is going to be distributed. over a Boolean expression. The expression I'm talking about here is a plus b. This is the expression we are distributing a to, and it is ANDed, okay? So this expression is ANDed to a, and that's why we're having an AND gate here, okay? So let's say a times b, we have ab. The plus sign maintains, then a plus c, we have ac here, and we've distributed a. As you can see, there's a here and there's a there. It has been distributed. Similarly, if we're going to use the OR gate, it's the same thing. If you do a, you distribute it to b, you're having a plus b. You distribute a to c, you have a plus c, and of course the AND gate maintains. So this is how you show the distributive property. Very vital. Now, the fourth property is the identity property, which states that any variable ANDed with a 1 or ORed with a 0 will always be equal to that variable. They've said any variable, okay? So I've picked b here. ANDed with a 0, ANDed with a 1. So this variable b, and there's an AND gate there, I'm ANDing it with a 1, is equal to that variable. Then here I'm using a variable. So a, when it's ORed with 0, which is the second statement here, if it's ORed with a 0, will always be equal to that variable. So you can note the keywords there, always, and any variable. So it doesn't matter whether you use c, whether you use d, whether you use f, as long as it's a variable and it's ANDed to 1, it will still give you the answer, that variable. Why it's called an identity property? Because it takes in the identity of the variable you're using. So because b is ANDed with 1, it gives me b. The answer is b because it's taking the identity of the variable I used. So let's say I use a. The answer here will also change. It's going to give me a. It has to take the identity of the variable I've used. So because I've used a, I'm getting a. If I use c, I'll get c. The conditions must be I should use the AND gate and I should AND it with a 1. That's the first statement. Then the second statement, to complete the entire identity property, the second statement says that ORed with a 0. So we have an OR gate here and a 0. So any variable, as long as it's ORed with a 0, it will give you that variable as well. It's identity property. So whether you are using AND gate or OR gate, the identity property will still be applied. If I use C here, it certainly means that even here, the answer will be C. So just don't mess up the gates. When you're using an AND gate, you're ANDing it with 1 or ORing it with a 0. That's when you get the answer to be that very same variable you are using. Okay, so moving forward to another property, which is a complement property, my favorite. Complement property states that the complement of a complement leaves the original variable unchanged. Simple English, straightforward. Complement of a complement. So when we have a single bar, it's just a complement. When we have 2 bars, that is complement of a complement, like what we're seeing here. This is how a complement of a complement looks like. Now, what does it do when it's, on top of a variable like this? It leaves the original variable unchanged. So what will be the answer? The original variable here is a. So the answer would definitely be a. Okay? So let me illustrate. That's a complement for illustration purposes. Please don't use a comma. Don't use this sign. Just make sure you use 2 bars. Okay, my PC is giving me issues, so I'll use these. So take this as a complement of a complement. It leaves the original variable unchanged. So if you have a complement of a complement, the original variable will remain as it is. Even if I had b, complement of a complement, will still leave the original variable unchanged.